And like, yes, dear students, am I audible? Please give a thumbs up in the chat forum. Am I audible? Okay, thank you so much for the confirmation. Now, so let's proceed with the webinar. So I welcome you all to the Head Start, and like it's a small step like we have taken for you so that you can ace your board examination that is on like 20th of March, 20th of Feb. Okay. Now, so moving ahead, so like how will this benefit you? Like how this webinar is going to be benefit you? So first we'll start decoding the syllabus of the subject, and then like moving ahead we'll see the exam pattern, the structure, like how the questions will be asked in the examination, like what are the marks weightage, like what is the question type and how much marks each type of questions can contain. Like after that, like we will analyze some previous year questions from physics. Okay, and then the common mistake that you should avoid while writing your examination, and some steps also I'll tell you so that you can manage your time, and like the skills and strategies that you can focus in these some days that you are getting for the preparation. Now, so here, like if we see the physics chapter, you can see these are the chapters that are coming in your examination, the light, reflection and refraction. You can see that this chapter is containing the 10 marks, isn't it? So like numerical part, I'll just say that practice the numerical parts from this chapter, reflection and refraction, along with the electricity. You can see these two chapters are like high scoring, isn't it? So first focus on these two chapters. Like you can see that human eye and the colorful world, it's containing 2 marks. So if you're like not completed your syllabus till yet, so first focus on the electricity and the reflection and the refraction. Just don't waste your time in the starting part. Just focus on the important topics, like what is the meaning of reflection, refraction, then the sign conventions that are used, ray diagrams. In electricity also same way, what is the meaning of electric current, flow of current, what is like potential difference, Ohm's law, and the combination of resistors. You can focus on this, like you will score good in these two chapters. And then moving ahead, next magnetic effect of electric current. So if we see this, like it's containing 6 months, there will be no numerical part from this, like, but the theoretical questions can be asked from this chapter. Okay. And like this is also just a easy one, just you have to know the direction, like from which direction like the current and the magnetic field, that's it. Now moving ahead, if we go in the chemistry, there is a chemical reaction and equation. This is containing 6 marks, acid, base and salt 3 marks. So like you can see acid, base and salt, it is containing 3 marks. So the chapters that are containing less weightage, I'll suggest you just focus on the chapters that has the high weightage. Like you can see metals and non-metals containing the high weightage, and a very like simple chapter. Just focus on the refining part of the metal, like what are the methods that are used in the refining. And then like the next, like the chemical property, chemical reactions of metals with other substances. Okay, focus on that. Then carbon and its compound. So like I will say the homologous series. Just give some time in the homologous series, and the next like the nomenclature part you can go with. And the acid, base and salt, like it's 3 marks. So like after completing all the chapters, you can go with the acid, base and salt. Then coming to the biology, like you can see like biology life processes containing 9 marks, control and coordination is of 6, how do organisms reproduce 3 marks, heredity and evolution 7. So first start in biology, start with life process, then go in the heredity and evolution. Okay, and if you see our environment, so like it's containing 5 marks, and like it's like just a easy one, like you can go with this chapter, like no need of like putting a lot of time. Just read the lines of the chapters from the book and you will be able to write the answers of this chapter. Now, so if we break up the question paper, like what type of question? So there will be like 20 questions of 1 marks, and that will be in the form of MCQ. Then moving next, then we have the short answer type question. There will be 6 questions of 2 marks. Then there is a 7 questions of 3 marks and 3 questions of 5 marks, and there will be the 3 questions of 12 marks. 3 questions, 4 marks each will be there. And it's a long answer question and the source based. So source based, like there can be like one questions from each. Okay. So there will be a passage given you, some informations are given at there. So to ace these source based or the case based questions, I'll just say that read the chapters carefully. At least one time, every student should read the chapter, understand the meanings of the words of the NCERT. Then you will be able to, you will easily like score these 12 marks. There will be no marks deduction from this part, I'll suggest. Now we'll see some questions here. So like a previous year paper analysis, like I have taken from physics part just because like if we see like the numerical part is easier, like we have the less time to cover all these things. So that's why I have taken the physics part and the numericals of this. So here, like, can anyone tell me what will be the answer of this? Like, if you're able to solve the first question, like the refractive index of diamond with respect to glass is like 1.6 and the absolute refractive index of glass is 1.5. Find out the absolute refractive index of diamond. Yes, if you are able to solve this, please write your answers in the chat. And or like you can give a thumbs up also, like if you are able to solve. Yes, now let's solve this. So here, like you have, so if we see the refractive index, so like in simple, what we can say about the refractive index. So refractive index, by getting the refractive index, we comes to know that how much times the light is traveling in that medium. Like if we talk about the absolute refractive index, for absolute refractive index, we compare the speed of light in that medium with respect to light, isn't it? So here, like in this question, diamond with like the refractive index of diamond with respect to glass is given. So what I can take, the refractive index of diamond with respect to glass. Refractive index of diamond with respect to glass that is given to us is like 1.6. Now the refractive index of glass is given, that is 1.5 to us, isn't it? Now, so we have to find the absolute refractive index of diamond. Absolute refractive index of diamond we have to find here. So the refractive index of diamond with respect to glass, what we can write, refractive index of diamond over refractive index of glass. So this value is like we are having 1.6 here, absolute refractive index of diamond, and the absolute refractive index of glass is given to us is 1.5. So just transpose this 1.5 to the left side, 1.6 times 1.5, you will get 2.4. Okay. Now, moving to the next question. Now, moving to the next question here, like we can see that how are power and focal length of the lens are related. So we all know like they are related. Like we know that power is like 1 over focal length, isn't it? Like P is equals to 1 over F. So we can say the relation is inverse. So if we increase the focal length, the power will decrease. And if we decrease the power, the focal length will increase. This is the inverse relation power and focal length of a lens is having. Now, so you are provided with two lenses, focal length 20 centimeter and 40 centimeter respectively. Okay, so which lens will you use to obtain more convergent light? See, like if you want if you want more convergence, so you have to use a lens which will have the more power, isn't it? And we know that like power and the focal length have inverse relation. So if we have a less focal length, then there will be more power. That is the inverse relation suggests us, isn't it? So we'll use a 20 centimeter focal length lens to get more convergent light, isn't it? Like power, like you will write 1 over 20 here. So like the unit of power is diopter, and 1 diopter is 1 meter. That means 100 centimeters. So if I write here 100, so this will be 5, isn't it? Power is 5 diopter. And if we take 40, so like this will be like 100 over 40. If you cancel, it will be 5, it will be 2. So you are getting 2.5. So the lens which is having 40 centimeter of focal length having a power of 2.5. The lens which is having 20 centimeter of focal length having the power of 5 diopter. So we'll definitely use like the lens which is having 20 centimeter to get more convergent light. Okay. Now, moving to the third question. So, Sudha finds out that sharp image on the window pane of her science lab was formed at a distance of 15 centimeter from the lens. Okay. So, like it's forming the image of window pane of her science lab. Okay. So, definitely like there will be a screen, isn't it? Now, she now tries to focus the building visible to her outside of the window instead of the window pane without disturbing the lens. So like you can consider, suppose here you are having the lens. Okay. And here we are having the screen. And here suppose the window. And there will be a building outside this window. Okay, so the window image is formed on this screen, isn't it? Like Sudha finds out the sharp image of window pane. Her science lab was formed at a distance of 15 centimeters. So this distance is 15 centimeters, isn't it? She now tries to focus the building visible to her outside the window. So this is the building that's it outside the window, and she wants the image of this window, this building on this screen. And what is the condition? That she is not allowed to change the position of this lens. Okay, so what she can do? So if we see like we have the convex lens, like a screen can be placed only for the convex lens. We can't place the screen for the concave lens. So we are considering that this is a convex lens to us. Okay, so you are not allowed to change the position of this. You just need to either you can move this screen away from the lens, or you can bring this screen towards the lens. So we have to find like what we can do. Should we move towards the lens or should we move away from the lens? Now, so the image formation, if we see for the convex lens, what we comes to know that if the object is coming closer, like if you remember like the image formation, if the object is at infinity, we get the image at focus. If we move ahead beyond F, we So we are getting the image at between second focus and 2 times of second focus, isn't it? At center of curvature, if we keep the image or object, we get the image at center of curvature on the other side, isn't it? So what it means, if we are going closer to the lens, the image is like, the image is becoming bigger, isn't it? And we want a sharp image. So you are not allowed to move this lens. So the building is going away. So the object is going away. So where should be the image form? It should come closer to the lens, isn't it? So if the object goes away from the lens, the image comes closer to the lens, isn't it? So that is showing us that we need to move the screen towards the lens. It should be shifted towards the lens to get a sharp image of the building. Now, along with that, it's also asking that what is the approximate focal length of this lens. Now, so if we talk about the focal length, can we able to find the focal length? Like we just have a value of V, like the image distance. You are not having U value, like what is the distance of this building from the lens. You are not having the focal length also. So like we can't able to, like focal length is asked to us. Suppose the questions can be framed in this way also, like there will be only one value will be given, either the distance will be given or the image distance will be given. So in that case, like there will be the magnification given. So here also, like if we see there is like the question is not talking about the magnification, like how magnified or like the image is formed, isn't it? So here like data is insufficient to find the focal length. Okay. Now moving to the next. Till I'm erasing the screen, you can read the next question, the fourth one. Now, CSJ students, if you have any doubts in the questions, like you can write in the class forum or like the chat also. Now, moving to the fourth question, the size of image of an object by a mirror having a focal length of 20 centimeter is observed to be reduced to 1/3 of its size. So there is an object, there is an image, and the image is reduced to 1/3. So that means if the object is of 30 centimeter, the image is formed of 10 centimeter, isn't it? At what distance the object has been placed from the mirror? So it's talking about the mirror. Now, so if we see like the image formation, like if we talk about, so there like a concave as well as the convex, both the image like the concave, convex, like this is, we are having a convex and this is what we are having, concave mirror. And both the mirrors form the magnified as well as the like the diminished images, isn't it? So this can be solved for both, like for the convex mirror also and for the concave mirror also. So 1/3, we talk about 1/3. So this is the magnification given to us. And if you relate in the previous question that I was talking about, that like we are having the image distance is given. How can we solve? How can we find the focal length? There should be magnification given. So here you can see just the magnification is given to us, isn't it? And the object distance, image distance, both are missing in this question. So it's a good question, like it will create a good concept for you all. Okay, so here so like if we talk about the magnification of the mirror is like minus V by U, we can write. So the value of M, if I'm calculating for convex mirror first. Okay. So like if we take convex mirror, so here like M value, we can take it as M will be positive. For convex, M is always positive. Okay, so we will take 1 over 3 here minus V over U. So like what you are going to get. So like you can write U is equals to minus 3V, isn't it? Now, what is the mirror formula? The mirror formula is 1 by F is equals to 1 by V plus 1 by U, isn't it? Like say, here like two variables are unknown. Like if you see V and U, both are the variables, like the values can change over the condition. So we are considering it as a variable. So if both the variables are unknowns, if they are not given, so definitely there will be the two variables, so there will be two equations. So here like one equation is formed and we will substitute this in the second one. The thing that you are doing in the linear equation in two variables in mathematics, the same concept you can apply here. Either you are studying maths or you are studying physics. In real life, if two variables are unknown, there will be two conditions and you can relate and like you can substitute the value. So here like in place, like this is 1 by V. Now here it's minus 3V. I'll substitute the value of U with minus 3V. So here this becomes minus and it's 1 over 3V. So the LCM, if we take, that will be like 3V. Here it will be like 2 minus 1. No, it will be 3. So 1 times, it's increased 3 times. So it will be 3 minus. So here 3 minus 1, that like, and here like focus. So focus is like what we have. If you remember the sign convention, this is the Cartesian plane. I'm finding for convex. So pole of the mirror should be placed at the origin of the Cartesian plane. So focus is at this side. So for convex mirror, focus is positive. So here I'll take it as 1 over 20. So now V, what you are going to get, like it will be like 40 over 3. Now, so you can see there is a positive sign in V. So positive sign is indicating that the nature is virtual, just because the image is formed at this site. So origin to X, there is a positive. We are having a positive. So image is formed, this will be our V. So if you are getting the value of V as positive, that suggests us that the nature of the image is virtual. Okay. Just because the image is not formed on the reflecting part, it is forming behind the mirror. So if the image is formed behind the mirror, that image is considered as the virtual. So nature of the image is virtual. Okay. Now if I calculate for concave, so let's erase this part. Now, so if we take a concave, the magnification is negative for concave. Okay. So now for concave. So for concave, like if we talk about, so like we can take minus 1 over 3 is equals to minus V over U, the magnification. So negative get cancel, you are going to get as 3V in this case. Now again 1 by F is equals to 1 by V plus 1 by U. Now 1 by V plus 1 by 3 V we will put. So here we are going to get 3V as an LCM, isn't it? And here we are going to have 1 over minus 20. Magnification. M is like negative, like focus will be negative for concave mirror. Okay, like why, if this question comes in your mind, why we are taking the focus of concave mirror as negative? So like this is the concave mirror, pole of the mirror will place at the Cartesian origin of the Cartesian plane. Here you have a focus. So now you can see origin, and this is x dash axis. So origin to x dash axis, we have a negative. So that's why like focus will be like negative 20. Okay. So here like this will be like 3 plus 1. Okay. This will be like 3 plus 1. Now, so 3 plus 1. So you are going to get it as like V. Just cross multiply. V you are going to get is at like minus 20. This becomes 4. This becomes minus 80 over 3. So negative sign, what it's indicating? The image. Suppose this is the object you place. So this will be your U. And like image is also on the left, just negative side. So suppose image is formed here. So this will be like negative V I will take. So negative sign is indicating, you can see the image is formed on the same side of the mirror, isn't it? That means the nature is real. And if it is real, then it will be inverted. Okay. Now, so this is how these previous questions were asked. This is how you can solve in the examination. Now, moving to the next question, it's from the electricity chapter. Like a child has drawn an electric circuit to study the Ohm's law. So what is Ohm's law? If we talk about the Ohm's law, like it's very simple. V is directly proportional to I. Okay, if you see the graph, it will be yours like this. His teacher said that the circuit diagram needs correction. Study the circuit diagram and redraw it after making all corrections. Now here, like you can see here, the first mistake you can observe here, whenever we are connecting the wires to the battery or the potential difference source, like one will be positive, like one end of the wire should be connected to the positive and one should be connected to the negative terminal, isn't it? The second, like if we talk about the voltmeter, what voltmeter does? In the circuit, it measures the potential difference. What ammeter does? Ammeter measures the current, and ammeter is always connected in series. So this should be the place of ammeter and this should be the place of voltmeter. Okay. Now the next question is from the combination of circuit. After this, like corrections, you can draw the diagram. Now the next part, like it's the combination of resistors. So if we talk about the combination of resistors, in two ways we connect the resistors, either by the series or by the parallel. So like what I feel that many a times the student face difficulty, like how we can relate that, like the resistors are like in series or in parallel connections. So what I do, this helps me a lot. So this is what I am telling you. You can also check like that. Suppose I current is flowing from here. In series connection, current is same throughout the circuit. Like if I'm drawing two resistors, current will be same. So here also and here also, the current will be same in both these two resistors. If they are parallel, then what will happen? The current will be distributed. In parallel connection, current is distributed. Okay. So here like I current is flowing from this end and it's going here, and you can see at this point some current will flow in this direction and some current will flow in this direction, isn't it? So that means here you can see there is a distribution of current, and the point where you find there is a distribution of current, what you can do, you can relate that it's a parallel connection. Okay, so and in this figure it's very simple, like to identify these two resistors are 2 ohm and 2 ohm are in parallel connection and this one is in series. So if we take the equivalent resistor at this, what we can do? So like 1 by R equivalent is equals to, like you can do 1 by 2 plus 1 over 2. So like here 1 plus 1 over 2. So that will be like 2 over 2. You will get 1. So you can redraw this diagram like this. So for these two resistors, you take one equivalent resistor with 1 ohm resistance. Okay, so this is 2. Now in series, like we normally add, like in series, like R equivalent is like R1 plus R2, isn't it? So this will be like 2 plus 1, 3 ohm. The equivalent resistor in this circuit will be 3 ohm. Now moving to the next one. Now the focal length of a convex lens is 25 centimeter. Express its power with sine. So it's telling us to express with power and with sine. So like, see, always remember, like many times what a student do the mistake when they are like always remember one diopter is like 1 meter. So like it's asking focal length. So power is equals to 1 over f. So what you can write? You can write it as 1 over 25. But like this is in meters, so just take 100 here. So 25 ones are 25 fours are. So it will be 4 diopter and it's a convex lens. Okay, so convex lens have a focal length positive, so it will be positive. Okay, so like if we see the sign convention here, we have the convex lens, isn't it? So like focus, we take focal length here we are having, isn't it? So for concave, it will be negative. Okay, for concave, it will be negative. Now, moving to the next. So a student focus the image of a candle frame on a white screen using a convex lens. He noted down the position of the candle screen and the lens as under. So here, like if we see this question, like position of candle, like you can see 12 centimeter, position of convex lens is 50 centimeter, position of screen is 88 centimeter, like how we can take. So again here, like what you can do, just try to draw the diagrams in the physics. If you are able to draw the diagrams, like half of the question, you will ace. Okay, so here, like what is happening, there is a screen. Okay, there's a convex lens we are having, and we have some origin. Okay, like I'm taking a fixed position, and there is a candle we are having that is placed. Okay, so definitely the image will be formed, isn't it? So what it's saying, from this point, like what it's saying, you can see position of a screen is 88 centimeters. So from the fixed point, position of a screen is 88 centimeter. This is 88 centimeter. Now position of like the convex lens is 50 centimeters. From this point, it is 50 centimeter. And position of candle, like it's telling that it's 12 centimeter. This is 12 centimeter from the fixed point. What is the focal length of the convex lens? It's asking the focal length. Now see, if you see, this is the object we are having. Okay. Now this will be the object distance, you can see, isn't it? This will be the like image will form here in the screen. The image will form like this on the screen. It will be the real, so it will be inverted. That's why I make the candle inverted here. So this will be our V. If we know U and V, we will find the F, isn't it? With the lens formula. So here, what is U? How you will find U? So from the starting point, lens is kept 15. centimeter. Candle is placed 12 centimeter from the starting point. So what is the distance of U? U will always be negative. So you can subtract 50 minus 12. So you will get negative 38 centimeter. Now, V, if we talk about V, so the hole is 88 centimeter. This is your V. So from this 88, if you subtract 50, you get V. And it's a convex. So image is forming this side. So V is our positive. We will take it as a positive. So it's 88 minus 50 we can do. So that we are going to get 38. Okay. Now, length formula if we talk about, so 1 by f is equals to 1 by v minus 1 by u. Okay, always remember subtraction is not commutative. Many a times I find that a student write 1 by u minus 1 by v. Okay, so don't do this mistake. So like v is 1 over 38. It can be positive. This becomes positive. U will be like 1 by 38. This becomes positive just because U is negative. So negative will make it positive. So here 38, here we'll get 2. So 1 time and it will be 19. So F will be like 19 centimeter. Okay. This part is done. Where will the image be formed if he shift the candle towards the lens? Now what is happening? The candle is shifting towards the lens. That means in this direction, the candle should be shifted at the 31 centimeter. Now this time from the starting point, the candle is at 31 centimeter. Suppose at this point, the candle comes. So again, like this time U will change and this becomes like negative like 50 minus, you will do 31. That gives you like negative 19. Isn't it? Now just observe one thing, like you are having a focal length of 19 centimeter and object distance is also 19 centimeter. That means object is placed at F, isn't it? So if you have practiced the image formation, what is the size, what is the nature of the image, like where the image is formed? If we place the object at focus, the image forms at infinity. And if we calculate this mathematically, like 1 by f is equals to 1 by v minus 1 by u. So v is what we are having. Our v is like we have to find the v. So f, we find f here, isn't it? F is 19. So we'll put the value of f, that is 19. We are going to find v. So here v, and this will be like positive 19. 1 over 19 goes to the left hand side. So 1 over 19 minus 1 over 19. You are getting v as 0. That means it's at infinity. Mathematically also you can see we are getting the image formed at infinity. Now where will the image be formed if like it's done? These two are done. Now the third one, this is the third one. Okay, what will be the nature of the image formed if he further shifted the candle towards the lens? So what will be the nature? So what we have learned in convex lens, if the object is shifted towards the lens at focus, the image forms at infinity. So if you shift again after focus, that means the object comes between focus and optical center of the lens. That is showing that the image will be virtual, isn't it? So in this case, the image will be virtual. Now draw a ray diagram. So if you have to draw the ray diagram, let me erase this one. Now you have to draw the ray diagram. So we'll take the lens. This is our principal axis. Here the first focus, 2 times of first focus. Here second focus, 2 times of second focus. Object, this is the optical center. Object is between focus and optical center. Ray of light parallel to principal axis. After reflection passes from focus. If you pass the optical center, like it will go undeviated, like these lines are never going to meet. So we'll take the virtual, and in this way, like you can say that here is the image form. So this is how we set the, we draw the ray diagram for the lens. Okay. Now the power of the lens is plus 2D. Find its focal length and state the kind of lens. So positive is indicating that the lens is convex. Okay. So the lens is convex we have, and like if the power is like this, so power is 1 over f. So like it's 2, and so we can write it as 1 over 2, that is 0.5 meters. That means 50 centimeter. Focal length is of 50 centimeter. Now the next question is from the electricity. So like the power consumption. So this is the part of the electricity chapter that we use in our daily life, isn't it? Like when you're paying the electricity bill, if you want to calculate, you can calculate, or when you're buying some electrical appliances, how much like that appliances put the cost for the electricity bill, you can calculate in this part, power consumption. So now the question is like a geyser is rated with 1500 watt and like 250 volt. Like the potential difference that this geyser requires is 250 volt. This geyser is connected to a 250 volt main. Okay, calculate the current drawn. So like if we know the power and we need to find the current, so like there is a relation that current is equals to power over potential difference. So power value is given to us, that is 1500 watt. V is given to us, that is 250 volt. Okay, we'll put 1500 over 250, 0 cancel, like 25 one time, it will be 6 times. So 6 ampere of current it will draw. Now the second part, the energy consumed in 50 hours. So energy for energy. So if we talk about energy, so energy is equals to power into time. So like it's consuming 1500 watt, and what time for 50 hours. So we'll multiply with 15 5s, that will be 75, 1230. That means 75,000 watt. Now 75,000 watt, you can convert this to kilowatt also. So 1 kilowatt is equals to 1000 watt. Okay, so if you divide, it will come 75 kilowatt. Okay, now so here rate is 4.20. So just 75 times of 4.2, you will get 315. So if you have to find the cost, so for cost, just multiply the power that you are consuming with the rate. So this rate is like per kilowatt hour. Okay, it's not for watt per hour. So that's why I have converted this 75,000 watt into kilowatt. Okay, so these are the types of questions that were asked previous year in the previous year examination. So you will find the numericals in these pattern in the on 20th. Now moving ahead, so like common mistake that you should avoid. So first, like whenever you got the question paper, I'll just say that you get some time for the reading part. Read the question carefully and try to mark the questions that you know very well and write that answers first. Okay, so Like the mistake that students do, that they ignore the instructions that are given on the question paper and misinterpreting the question and rusting to answer. So this is what, like, you're getting a time for reading the question, read the question carefully, frame your answer in your mind, and then start writing. Don't be in a rush to write quickly. Okay, and write appropriate answers. Not like just if it's a 3 marks or a 2 marks question, like many times, like how much we should write. Just answer in point wise. Okay, don't go in writing in paragraph. If 2 marks question, write 2 points. That's it. If it's 3 marks question, write 3 points. That is enough. Okay, and like if there is any like a 5 marks question, so like in that, like if you are able to give some example, illustrate your answer with the examples also. Okay, and try to take care of your handwriting in a rush. Don't like just write in a lazy way. Okay, so your handwriting should be also like whatever you are writing, it should be neat and clean. Okay. Now, so time management. So if you read the question carefully, you will be able to know. Always write the answers that you know first. So if like, and when you know, you comes to know that, okay, these much questions I'm knowing, set a time in your mind, like I will complete these all answers in this much time. And then comes to that question, which you know partial. Okay. And then go in that questions for which like you are not knowing anything, but like some words you are knowing for that. So try to illustrate your answer, whatever you are knowing for that question. Like that you can go. Okay. And use the diagrams to illustrate. Okay. Write concise and to the point answer. So this is what, like point wise, right? Point to point. Okay. And this is what we have. So all the best. Stay focused. Give your best. You have so many time for the study. Okay, so study well. Figure out the important points, important topics. Take the bullet points. Note down. So at the time of like when you are at your examination center, you want to revise any chapter you are feeling like it's little complex for me. So just go with that bullet points that you can do. Okay, so this is all I'm having for this session.
Thank you very much, Rupesh. It was a fantastic session. I'm sure the students have enjoyed the session very much. A lot of information came through from this session. So, students, thank you very much for joining in for this session, and all the very best with your science examination. Do well in your exams and score well in your board exams. Okay, thank you very much, everybody.